Assalamualaikum warahmatullahi wabarakatuh. Welcome back to our virtual classroom with me, Miss Yana. I hope you guys are well and ready for our class today. So today we are going to learn on topic limit and its relation to differentiation. This topic is in chapter 2 additional mathematics form 5. Okay, so in this topic, what you will learn? Students are able to determine the first derivative of a function f(x) by using first principle. Okay, but before that, I want to recap about what we have learned last week. We learned about on how to solve a limit. Basically, limits have three ways to solve, which are direct substitution, factorization, and conjugate. Let's take a look on the first way, which is direct substitution. Okay, so for the direct substitution, I provide you an example. Okay, so we look on the example. The question is limit 3 minus x over x plus 2, which x approaching to 4. So what do we have to do? At the first place, when we're talking about limits, we have to substitute the value of x into the function. So we will substitute the value of 4 into this function. So we substitute 4 into the x and we solve it and we will get the answer 1 over 6. Okay, so for the second way to solve a limit is factorization. As I said before, you have to do substitution first. Okay, this is because as you can see here, I substitute the value of x, which is 1, into the function, and I got 0 over 0. 0 over 0, we call it as indeterminate form. When it is indeterminate form, we have to do factorization. Okay, as we can see in this function, what we can do is only factorization. Okay, so this function x squared minus 1. X squared minus 1, we can factorize it. So we will get x plus 1 and x minus 1. Okay, so here we get a new loop of a function. It is a function, but a new loop. Okay, so as we can see here, x minus 1 and x minus 1, we can eliminate it. Okay, so we eliminate it and we will get this function, limit x plus 1, x approaching to 1. And what we have to do? We have to substitute 1 into the function. Okay, so the value of x is 1. 1 plus 1 is equal to 2. Okay, so the third way to solve limit is conjugate. Okay, how we want to know? When we want to use conjugate method, we have to use it when we found this. Yeah, what is this? This is set, or we call it as square root. Okay, so we can see the question. Limit set x plus 1 minus 1 over x approaching to 0. So we substitute the value of x into the function, and yes, we got indeterminate form again. Okay, so what we have to do? We have to do a conjugate. Okay, so here you can see here is the sign minus. Okay, so when we want to do a conjugate, we have to change the sign to, okay, if the sign is negative, so we have to change the sign to the positive. So when we already write this out and we multiply it, and we will get this answer. So this answer, what we're going to do next is you can see the third and x squared, 8n squared, third and squared. Okay, so we can cancel out this third and third and square, so we will get x plus 1. And while 1 square is 1, okay, so we will write back, and we can see here we got this loop, and then we just 1 minus 1 we can cancel out, so absolutely it is a 0. And x with x we can cancel it out too, and don't forget there still have a value on the top of it. Okay, so we get limit 1 over z x plus 1 plus 1 as proportion to 0, and we try to substitute the value of x into the function, and yes, we got the answer 1 over 2. Okay, so that's all for the recap session. Okay, so we're back to our main topic for today, which is first derivative of a function f(x) by using first principles. Okay, so here is the formula gradient of tangent equal to y2. So here is the formula gradient of tangent equal to y2 minus y1 over x2 minus x1. Okay, so this formula will be used when using a graph to obtain the gradient of the curve. By using the idea of limits, we can find the gradient of the curve at a particular point. So it will make your calculation more easier. Okay? So here is the important formula in this subtopic, which are gradient of line and gradient of the curve. Okay, we take a look at the first formula, which is gradient of line. Okay, so gradient of line, how to find delta y. So this is delta. This is we call delta. Okay, so how we want to find delta y is y plus in a bracket y plus delta y minus y. Okay, so same goes to delta x, and here is the gradient, is the formula for the gradient of line. The second formula is gradient of curve, which is we use the limit to find the gradient of the curve. Okay, so limit delta y over delta x approaching 0. So to make you clear about this, let's relate while answer some questions. Okay, so here is the question. Find delta x. So here is the question. Find delta y over delta x by using first principle for each of the following functions y equal to fx. So the first question is y equal to 3x, and the second question is y equal to 3x squared. So let's take a look on the first question first. Okay, y equal to 3x. I'm so sorry because I didn't bring back my writing pad, so I write I put. I'm so sorry because I didn't bring back my writing pad, and I have to just show you the answer without showing you calculation, a proper calculation. Okay. I'm so sorry because I didn't bring back my writing pad because I'm so sorry because now I am at my hometown and I didn't bring back my writing pad. So to make it easier, I just put this calculation here for you to understand the calculation. Okay, so here the first answer, the first question, y equal to 3x. So we y equal to 3x, y equal to fx, and fx is equal to 3x. Okay, and the second one we have to find f x plus delta x. So we just focus on here, okay, and here. So what we change is only at the x. So we simply substitute the value of x plus delta x into the x, and we get 3 in bracket of x plus delta x. Okay, so next we already got delta y, which is delta y equal to 3 in bracket of x plus delta x and minus 3x. Okay, so we expand it. Okay, expand 3x and delta x with 3. Then we will get delta y equal to 3x plus 3 delta x minus 3x. And we can cancel off 3x and negative 3x. And we get delta y equal to 3 delta x. So what we want to achieve? We want to know the value of delta y over delta x. So what we can do is we just bring the delta x to the other side, and we will get delta y over delta x equal to 3. Okay, so here is the second formula that I show you just now. Okay, so we already get the delta y over delta x. So we just substitute the value 3 into this function, and we will get dy over dx equal to limit 3 delta x approaching to 0. Since the function here is only 3, so we don't need to substitute any value to the function, and we get dy over dx equal to 3. Okay, so for the second question is y equal to 3x squared. Y equal to 3x squared. So as I said before, y equal to fx, and fx is same as value of y, which is 3x squared. And then we find the f in the bracket of x plus delta x, and we will get 3 in the bracket of x plus delta x squared. Okay, so we find the delta y. Okay, so the delta y is 3 in the bracket of x plus delta x squared minus 3x squared. Then we have to expand it. We have to expand it to make it more clear, and we can eliminate what we can eliminate. Okay, so we expand this, and we get 3 in the bracket of x squared plus 2x delta x plus delta x squared minus 3x squared. Okay, so then we expand again. We do step by step. I prefer do step by step. If you are not clear, you are afraid of careless, so you have to do step by step. Okay, so we expand it again, and we get 3x squared plus 6x delta x plus 3 delta x squared minus 3x squared. Okay, here we can see 3x squared and 3x squared. Okay, so we can simply cancel out. 3x squared minus 3x squared is 0. Okay, so then we will get 6x delta x plus 3 delta x squared, and we factorize it. We factorize it, and the delta x is at the outside. Okay. So then we move the delta x to the other side, and we will get the value of delta y over delta x equal to 6x plus 3 delta x. Okay, here again, we use the second formula, and we already get the value of delta y over delta x. So we just substitute it in the function, and then we get the dy over dx equal to limit 6x plus 3 delta x approaching to 0. And since here we have delta x, so this the limit showing that delta x approaching to 0. So we have to substitute 0 into this function, and then we get 6x plus 3 times 0 is 0 lah. Okay, so we get the answer dy over dx equal to 6x. Okay, so I hope you can understand about what we learned for today. It may look simple, but sometimes you are careless or you are not remembering the formula. It will make you difficult to answer this question. So yes, thank you for watching. And if you have any comments or questions, you can leave at the comment sections. Thank you.